In this video we're going to continue with the topic of polynomials, and we're looking at determining the equation of a graph. Now normally we are given the equations in the question and then we need to work with them, whether that be finding unknown constants or solving them, proving that certain numbers are roots. So we're actually working backwards this time because we're trying to find the equation given the graph. So if we know the roots of the equation, we can see that on the graph, and we've got at least one other point on the graph, then we can actually establish the graph's equation quite quickly. So if we look at this first example, we've got a cubic that we've been shown in the diagram, and we're looking to find the equation of it. Now you can see here that obviously a cubic has 3 roots in this diagram, and you can see that we've got this other point that we talked about up here. So we've got the point 0, -36. So I'm just going to record what roots I've got. I've got x equals -6, x equals -3, and x equals 1. And remember, those would then imply that I have these 3 factors: x plus 6, x plus 3, x minus 1. So you might assume at this point that my equation is y equals x plus 6 times x plus 3 times x minus 1. However, if I plotted that, I would get this. And you can see that my 0, -36 doesn't lie on that graph. So what I need to do is introduce some constant. We'll call it k. And this will allow us to use this other point on the graph and therefore allow us to know what this value is here. So if we use 0, -36, you can see we've got an x ordinate and we've got our y ordinate, and we can substitute these in. So that will give us -36 is equal to k times 0 plus 6 times 0 plus 3 times 0 minus 1. So that gives us -36 equal to k times 6 times 3 times -1, which on the right hand side is -18k. And dividing throughout by -18 gives us k equal to +2. So putting this back into our equation that we had the sort of more general form of, the y equals k, x plus 6, x plus 3, x minus 1, we now know that the equation of the graph is y equals 2 times x plus 6, x plus 3, x minus 1. And that's our final answer. We could expand the brackets, but we don't generally have to do that. So unless the question asks you, you can just leave your answer like this. So just now would be a good time to pause the video and take this example down in your notes. Okay, welcome back folks, and we'll look at example 2 now. So this time we're going to look at an example that has repeated roots. So if we just remind ourselves what a repeated root is, if a repeated root exists, then it means that a stationary point lies on the x-axis. And we can recall that a repeated root exists when 2 roots, and hence 2 factors, are equal. So we'll look at what this means for this example here. So we've got another cubic, and we can see it cuts the axis twice, and it's only twice because we've actually got a stationary point, a turning point, sitting on the axis. So you can see it's a turning point, but also a root. So the roots that we have then are x equals -2, and then we've got this repeated root. So I've written x equals 3 twice to denote that repeated root. Now, that then implies that we've got 3 factors. We've got x plus 2, and then I can combine my repeated root here, x minus 3 all squared. I know from the previous example that generally if I plot y equals x plus 2, x minus 3 all squared, I'm not going to get this graph. I really need to be able to use this other point. I mean, it's been given to me, and generally information which is given is there to be used. So y equals k times x plus 2 times x minus 3 all squared. So we've got that point 0, 9, so we want to use that and substitute into the equation. So that'll give us 9 equals k times 0 plus 2 times 0 minus 3 all squared. And 9 is equal to k times 2 multiplied by, remember, negative 3 all squared gives us positive 9. That's the same as 18k on the right hand side, and dividing throughout by 18, well, k would be 9/18ths, which is the same as a half. So the equation of that graph then is y equals a half times x plus 2 times x minus 3 all squared. So before the screen goes blank here, it would be a good idea to copy this down in your notes, and you can try the assigned exercise for today.